First thing I recommend downloading when you're writing patches or testing them is Zephyr. So this is a nested X server that's going to run as a normal X application within your other window manager, or even within DWM. You could have DWM running inside of DWM. To show you what I'm talking about here, I have a script that I've written just to execute DWM inside of Zephyr. So if I run this, you'll see this is default DWM running as an application window inside of my window manager. So I'm going to close that. If you're on Arch, it is within this package. I'll have that linked. And if you're on Gentoo, it is within X11 base Xorg server. And yeah, so go ahead and get that. It's super easy to use. This shows how to do it, and I'll show you my little script here. It just runs Zephyr just as shown here, but with a different resolution. This is the size of my monitor. You're going to fork to the background, and then I like exporting the display, so you can just run these commands as usual. Here I'm running DWM in the background, and then FEH to show my wallpaper when I run it. All right, so the first patch I want to take a look at is attach bottom. This changes the default behavior when you're spawning windows in DWM. So I'm going to go ahead and run this again. And when you're inside Zephyr, to lock your input and your mouse to Zephyr, you have to press Control and Shift one time. And now my mouse can't leave. Usually I can just go to my other monitor, but now I can't. And when you go to spawn windows, they will actually spawn inside of here. So, okay, to show you why I want the attach bottom patch. This is my first spawn window, and you can see as I spawn new windows, it's getting pushed further and further down. New windows become the new master, and this gets pushed all the way to the bottom of the stack. I want the exact opposite happening. When I spawn a window, I want it to stay there and not be moving around. It's kind of disorienting, and I just don't like it. You don't have to want this patch to follow along. This is more to show the code so you can get familiar with it to write your own patches and fix other ones if you run across any bugs. So I believe this is the most current version of the patch. I hate that they do this. I don't know which one actually comes first, but I assume it's this one. So I'm going to copy the link and I'm going to wget it. So that's going to download it. And now this patch file is here. So instead of just applying it, we're going to just read the patch. I had the other one downloaded earlier, but I think this is actually the newer one. Cool. So if you're not familiar with this, this is showing the difference between the original code and the code that the patch adds or removes. Here at the top, you can see what file they're talking about. So this is dwm.c. If you look for anything that starts with diff, so --diff, that'll show you the changed files. There's only one changed file here, which is dwm.c. So that's all we're looking at. First thing we're going to notice is they have written a function called attach bottom. The usual function that's executed, if you read through the code, when you're adding or attaching a new window or client, is just called attach. The content of the function is going to change the list of clients and how they're structured. So if you want, you can go read the actual attach function. We might get into that a little bit later, but going over what this actually does. The first parameter here is a client. This is, if you haven't seen my other video, this is a window, an X11 window with some extra metadata. The window itself is just an identifier. It's a unsigned long, if I remember correctly. The client itself is a struct that is in DWM that has its like position, its size, border, floating and full screen, all of that. But here, the only property you really need to know about is this next property. So this next property is the next client in the list. So what do I mean by list? If you haven't seen my other video, I'll explain this again. This is the first spawn client in my system. And if you know the master and stack layout, you have your master window, and as you spawn windows, it adds it to the bottom. So, or if you're on default DWM, it's the other way around, but same properties apply. This is my first client, and it has a pointer to the next client, which is going to be this one, because this is the second one that was spawned. And this is going to have next property that'll point to the third, and this will have one pointing to the fourth, and so on. So looking at this function, we are going to be constructing this new, it's essentially a a pointer to a list of other clients. If you're not familiar with C or any languages that deal with pointers, don't really need to fully understand this, but this will kind of give you an idea. So first thing we're going to do is we're going to say the client's next property is assigned to null, and that's because if I spawn a new client, there's nothing that comes after. So it should be null. It shouldn't point to anything else. Now this for loop, you'll notice doesn't actually have a body. It ends in a semicolon. That's a way to call the last, like the body, I guess, the last parameter over and over again until this condition is falsy. So first thing we're going to do is we're going to grab the first client on this monitor, essentially what this does. So each client struct also has this MON, short for monitor, and each monitor has a list of clients. And this list of clients is essentially just a pointer to the first client, but it's considered a list because you can go from one client to the next, to the next, to the next, because they all have pointers from one to the next. Okay, so done beating that dead horse. What this is going to do is it is going to assign this variable to be the next window over and over and over again. So eventually you will find a window that is null, and that would be, let's say in this case, if you're iterating, it's going to go, remember this is pointing to the first client, and it's going to find the next, which is this, and then it is going to find the next, which is this, and then when it goes to try to find the next, this is going to be assigned to null. So this is going to stop running, and now it will reassign this client's next property to C. And remember, C, this first parameter, is this newly spawned window. So getting next, is it null? No. We're getting this as next, is it null? No. And then it's going to try to find another window, and it's going to say, oh, there's no next property here, it's null. So this will terminate, and now this is pointing to this window's next property, which is supposed to be the new window, and it's reassigning it to the newly spawned window. So that reorders the stack. Instead of spawning it first, it's going to keep going till it finds a null next property in the list of clients, and it'll assign the new window there. So this is basically the logic of saying, hey, put the window at the end. We're going to go through all of them, and there's no window. Okay, put the window here, and it sort of wires up the next property from the previous window. So we're going to go through and look at the other changes. There are very few. This is a super short patch. I'm assuming that they have removed every single instance of attach is what it looks like, and replaced it with attach bottom. And here C is a client. You can go through and look at, if you're not familiar with Git patches, this is saying it's inside this function called update geom, which is short for geometry. And it is removing this. It's leading with a negative sign or minus, whatever. That means that this is getting removed. My syntax highlighting shows removals in red. And then the plus is in addition. So that is adding attach bottom, which is shown in green. So you can see like these are all added. This is added, 3 removals and 3 additions. So that's this entire patch. So we're going to go ahead and apply this. Applied, and now the code has been changed. So if I do git diff dwm.c, we get the same exact patch, which is kind of how those are generated in the first place. First, we are going to build DWM, so we just call make. And if you recall from looking at this, this is just running my local DWM. So ./DWM, that's this one that's being built. If you want to actually install it, you have to run sudo make install. So let's go ahead and run this. And remember to lock your input, pressing Control and Shift. Now your input is locked to this window. And by default, spawning a terminal in DWM is Alt, Shift, and Enter. So let's get some output so we can show that this is our first window and spawn some new ones. And they're getting spawned further and further down. And to show that again, you can see that is keeping this and it's attaching it to the bottom, which is what the patch is supposed to do. So that works. And yep, that's that patch. It's really useful. I like this a lot, and it's a very short patch to showcase. There are some other ones like actual full screen. We can show you this. Let's copy this link, and I'm going to wget it. So now we have this patch, actual full screen. So to talk about what this patch actually does, usually in DWM, if you're just starting out with no patches, you can't really full screen a window manually with window manager key bindings. The best you could do is the monocle layout, which still shows the bar and might show the border. I don't really recall. The only way to get a window to actually be full screened is if the application requests for it to be full screened. There is a function inside of dwm.c, if we look at that, called full screen. Oh, here it is, set full screen. So this, I mean, you don't really need to know about it. It's pretty simple, is just making the application full screen. And this is saying like whether or not you should full screen it. So if we look at this patch, say actual full screen, it looks like they add a new key binding here. This is in config.def.h, and this is in the static keys array. So if you've looked at that, this is where your key bindings are set. This is an addition. They're saying if your modifiers are mod key, whatever you have set that to, that's alt by default, and shift. So alt and shift and F. So this XK is a prefix for everything. You can see it. XKM, that's the M key. XK space is space. This is F. It is going to invoke toggle full screen. And this is saying essentially that they're not passing in any parameters. So toggle full screen is the new function that's being added here. So now this is in dwm.c. There's an additional function called toggle full screen. They decided not to spell out the full word screen, which kind of bothers me. But whatever. So here they're checking if the selected monitor has a window selected. This is kind of a null check in SEL. Here onside the monitor struct is a client. So if there is a client that's selected, which essentially means there is a client, it is going to call set full screen. It passes in the client, the selected client, and it is going to invert the Boolean to see if the selected client is already full screen, then this is going to say, okay, make it not full screen. Or if this is false, is full screen is false, it's going to invert it and say, make it true. So that's why this is a toggle. It is going to switch the state back and forth. And we just looked at set full screen. They didn't even have to implement this. So this is a super short patch. It's like 50 lines and very basic. So I'm not going to apply that. Very easy to go through and read. I guess the last one we'll look at is bar padding. Oh, they actually put dates here. Nice, because these patch names mean absolutely nothing. Copy link. All right, let's wget this. You could just view it in your browser, but there's absolutely, it's terrible. It's all black and white. I dislike it a lot. All right, bar padding. So there are a couple variables that they have added. There is vert pad and side pad. So this is vertical padding. They were nice enough to add a little comment here, vertical padding of the bar. So if you have a bar at the top like I have here, the vertical padding as shown here would add space at the top. So this means the bar is moving down by the number of pixels specified here. The default 10 for both. And side padding is padding on the sides. So instead of being all the way on the left side of the monitor, it would be 10 pixels to the right. And instead of touching the right side of the monitor, it'd be 10 pixels to the left. 10 pixels from the right, which is to the left. And this is just in your config. So it gets loaded from here whenever you build DWM. And here in the source code, this is dwm.c. Around the top of the file, there are a bunch of static variables declared. So in regular cyclist fashion, they keep the variable names super short and obscure. but at least we have these. They directly associate with these two variables. So this is vertical padding and this is side padding, or horizontal if you want to think of it that way, because that makes more sense. Now here, when maybe I should show this as an example, this function x move resize window, this is built into xlib and it does what you think it does. It moves and resizes a window. So you can pass in the x and y locations of the window and the width and the height of the window. So it looks like it removed this line, added this line, but all it really did was modify some of the parameters. So if we go here comma by comma, this is the X display. This is the bar window because that's the window that we're modifying. So M is a monitor, bar win is short for bar window. WX means the X location of the monitor. It's a little weird to think of, but if you had multiple monitors, this would be 0, 0. And then if I have one to the right of me, so just past my cursor up here to the top right, the X location would be at 1920 and so on. So that's what this is. So if it is your first monitor, this would be 0 on the left. And then we're adding SP, which is side padding. So it'd be 10 pixels in from the right if you're keeping these default values. And then pretty much the same thing for the Y. If you had monitors listed vertically, if you had one down, it would be like 1080 plus VP, which is 10. So essentially, this is just finding the monitor's position within the X display and adding on the side padding and the vertical padding. Here for the width of the bar, so WW is the width of the actual monitor itself, and it is going to subtract the side padding times 2 because you want to remove 10 pixels from the side here and takes 10 pixels from the side over here. So in total, that's 20. So yeah, and then the height of the bar is always the same. So that is going to move and resize the bar to match where you want it. And this is just in configure notify, which you can go look at. This is when you receive configure events for Windows and things. So let's look down at the next place where they changed stuff, and it is going to be pretty much essentially the same kind of logic, but instead of modifying the size of the bar, it is modifying the contents. So this is a draw text function. There's a drw.c that they've written, which has this function inside of it, which takes a few things. This is their like draw object or context. And here, this was the monitor width. And instead of just subtracting this, they are also subtracting the SP. So it's, remember, side padding times 2. So they're kind of giving the width of the bar, which is now the width of the screen minus the side padding on both sides. And the height, of course, is the same. We're not modifying the width, or we're not modifying the height of the bar. We're modifying the position of the bar. So this is the only modification here. And this is very similar stuff here. I'm not going to go through and explain this. This setup function, this is called sort of before DWM is ready to run other windows. It is going to be assigning SP and VP to whatever we are specifying, again, here at the top inside our config. So the only thing to look out here, there's direct assignment for side padding, but for vertical padding, it's a little different because it's checking if the bar is on top. So if it is on top, we are going to push it down by vertical padding, which is 10. It would go down 10 pixels. But if this is false, that means the bar is on the bottom, and we need to push the bar up 10 pixels. In computer space, it is a grid where 0, 0 is your top left, and your positive axes are down to the right. So in my case, this is 0, 0, and the bottom right is 1920 by 1080. That's why it is negative to go up and positive to go down. And then there's a few other cases here where they're updating the bar position during setup. And this is creating the bar window. and so on and so forth. It's kind of basic logic. You can go through and read the math and assignments to kind of figure it out from there. But I figured that would give you enough context where you can go in and do some crazy weird stuff with your bar if you wanted to. Change the order of your client assignments and so on and so forth. So again, just remember when you are testing these things out, it is very beneficial to be running things in Zephyr like I was saying here. You can use get apply and pass in this downloaded patch or any of the downloaded patches. The only real issue is if you apply patches on patches, they start conflicting with each other, and then you need to go in and manually resolve it. So that's why knowing this stuff is also very beneficial, even if you don't know C very well or really at all. If you just have some other coding experience, you should be able to go in and figure out, oh yes, I want this and that if you run into Git conflicts. Maybe I should make another video about resolving Git conflicts, even in this context or not. It's just something very useful to know. All right, so if you have any requests for any other patches you want me to go over, requests for ones to make, or have anything specific that you want me to look into if you're running into a problem, let me know in the comments or email me or find me on IRC.